Good day, students. Welcome to mathgotserv.com. In this clip, we're going to be going over how to write equations of a line parallel and perpendicular to another line with a specified point. Okay? All right, instructions for the examples are for us to write the equation of the lines parallel and perpendicular to the given line through the given point. So let's say that for this example, question number 1, we have the line y equals 1/3 x plus 2, and we want to find the equation of the line parallel and perpendicular to this line going through the point 3, 2. Okay? All right, let's take a look at it. So for this one, we're going to start by writing down the equation of a line that is parallel. Okay, we're going to do parallel first. So parallel. To write the equation of a line, we need two ingredients and the point slope formula. So these are what we need to write the equation of a line. We need one, we need the slope, m, and two, we need a point. All right, x1, y1. So what we'll do is we'll take these two pieces of information and we're going to plug it into the formula for the equation of a line, which is y minus y1, the y coordinate of the point, times mx minus x1. Okay? All right, so let's start with parallel line. So how do we find the slope of a parallel line? We'll take a look at the original equation, y equals 1/3 x plus 2. Okay? We need to find the slope of this line, so we can find the slope of the parallel line. So to find the slope of this line, we're going to use the formula y equals mx plus b, the slope-intercept form of the equation of a line. So m is the slope, the coefficient of x. So we can see clearly that it's 1/3 here. That's the coefficient of x. All right. Now for a parallel line to this given line, the slopes are exactly the same. So m parallel is equal to m. So the slope of the parallel line is the same as the slope of this line, so it's also going to be 1/3. That's the first piece that we need, the slope. Now we need a point. The point, x1, y1. So the point is going to be 3, 2. And this helps us see that the x1 is 3 and y1 is 2. All right, so now we have all the ingredients to write down the equation of the line. We're just going to write down the formula, point slope formula for the equation of a line. Y minus y1 equals mx minus x1. We're going to be using m parallel in this particular case. So we have y minus y1, which is 2, is equal to m parallel, which is 1/3, x minus x1, which is 3. All right? So ladies and gentlemen, this is the point slope form of the equation of a line parallel to the given line. So point slope form. All right, and then let's also write it in slope intercept form. To get it in slope intercept form, we're just going to simplify and isolate y. All right, so to do that, distribute 1/3 across these two terms, the x and the 3. Bam, bam. And then we have y minus 2 is equal to 1/3 x minus 1/3 times 3. Okay? And then we have y minus 2 equals 1/3 x minus, and then these 3's divide out. Bam, bam. All right, and then that's going to give us 1. Y equals 1/3 x minus 1. And then to finish it off, we'll just simply add 2 to both sides of the equation, and that will result in the isolation of y. And our final answer is going to be y equals 1/3 x plus 1. All right, so let's call it y parallel since it's parallel to the original line. And this form that we have right here is the slope-intercept form, the slope-intercept form. Okay, now let's go ahead and take a look at the equation of a line that's perpendicular to the given line. So the steps are exactly the same, but we're just using a different slope here. All right. Okay, so to start off, we need the slope of a perpendicular line. So we'll start with the original, which is y equals 1/3 x plus 2. All right, and then we need the slope of this line. To get the slope of this line, we're going to use the y equals mx plus b formula. All right, m is the coefficient of x, so m is 1/3. So what's the slope of the related associated perpendicular line, m perpendicular? Well, it is the negative reciprocal of the slope of the original line. Okay, so m perpendicular is going to be, you do the opposite and you flip the numbers. So it's going to be negative, since this is positive, 3/1, which simplifies to -3. So that's the slope of the perpendicular line. We also need a point. So the point is same as the other one, 3, 2. The point is 3, 2. All right, so x1 is 3 and y1 is 2. Now we're going to put it all together with the point slope formula. Y minus y1 equals m perpendicular in this case, x minus x1. We'll plug everything in. We have y minus y1. Y1 is 2. Y minus y1 equals m, which is -3. X minus x1. X1 is 3. Okay? And then, ladies and gentlemen, this form that we have right here, this is the point slope form. Point slope form. Now we're going to go ahead and write the slope intercept form. In order to do that, we need to get y by itself. And simplify and get y by itself. Okay, so distribute this -3 across these two terms right here. And that would give us y minus 2 is equal to -3x. Fix this. -3x. And then -3 times -3 is +9 plus 9. And then to get y by itself, you simply add 2 to both sides of the equation. And then you have y is equal to -3x plus 11. And there goes the equation of the line in slope-intercept form. Okay? So this is y perpendicular. And it's in slope-intercept form. All right, so let's go ahead and graph all the lines and see, so we can have a visual understanding as to how they are related to each other. All right, so we're going to take a look at the graph now. All right, so we're going to start with the going on. So we're going to start with the original line. Let's call that y original. So that one is 1/3 x plus 2. So we need the slope is, we need the slope, which is m, that's 1/3. So we're going to rise 1, run 3. And then we're going to begin at the y-intercept, which is b, and that's 2. So we're starting at the point 0, 2. Okay, so let's go ahead and graph that. Set up our coordinate system. Let's bring it a little bit lower. Okay, so starting from 2, 0, 2, we're going to rise 1 and run 3. 1, 2, 3. There you go. Okay, rise 1, run 3. All right, let's go ahead and draw that line. So that's going to be the original line. Okay. And then now what we're going to do next is we're going to go ahead and draw the equation, graph the perpendicular and parallel lines. We're going to do the parallel lines first. So the parallel line to this through the given point is, let's make it green. Y parallel is 1/3 x plus 1. So remember, it has to be parallel to the original line, and it has to go through the point 3, 2. So the slope m is 1/3. So we're going to rise 1, run 3. And then we're going to start at the y-intercept b, which is 1. Okay, so we're going to start at the point 0, 1. Okay, so let's graph it. So the point 0, 1, right here, starting point, we're going to rise 1, run 1, 2, 3, bam. Okay, so we see how it goes through the desired point, 3, 2, and it's parallel to the original line. Basically, it has the same slope. All right, so it goes right through there like that, bam. So the whole idea of being parallel just means that they have the same slope and they never intersect. Okay, so that's basically what we have here. And then the last one, we have y perpendicular. So for y perpendicular, let's make it red. Y perpendicular is, we got -3 x plus 11. All right, so we start at 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So to draw the equation of this line, we need the slope, right? So the slope m is -3. So write it as a fraction, okay, -3/1. So we're going to fall 1 and run, fall 3 and run 1. We're going to start from the y-intercept b, which is 11. So that's at 0, 11. Okay, so let's go ahead and graph the lines. This is y-axis, x-axis. This is y original. No. This is the original line, y sub 0, which is 1/3 x plus 2. And then this is the other one, y parallel, right, which is 1/3 x plus 1. Okay, and then to graph this one, we're going to drop 3 and run 1. So 1, 2, 3 over 1. Drop 1, 2, 3 over 1. And then drop 1, 2, 3 over 1. Bam, bullseye. Works perfectly. All right, so let's go ahead and draw the graph of that line. We're going to make it red. Okay, so we're going right through these points right here, like that. All right, so that's the graph of the perpendicular line. All right, so remember what perpendicular lines are. Perpendicular lines are lines that intersect at 90-degree angle. So this is y perpendicular. Let's indicate it right here. So y perpendicular is, what is it? -3x plus 11. So to indicate, to show that they're perpendicular, you just use a nice little box. That's how you mark it, right? This is perpendicular to that. That is 90 degrees. And then to show that these two lines are parallel, you just use arrows right here. All right? So there you have it.